aba mpiwe iraje ndakura ijwi giyeho ese imodoka itarageraho ya fuyo kwanza ni kuto ndiko ndio Yemats başlaması koydu. Bueno, hiç sabahleyin de şöyle. Daha yine bu sefer koydu. Welcome everyone. Nasıl bu geleyim mi? Nasıl bu geleyim mi? Вот тут Сава. Hello everyone. How are you doing, dear students, dear my friends? We remain with some. Let me set time, please. Seconds, like 40 seconds. Yes, if you are new, you are welcome. You are welcome. Noari Dani, how are you doing? Noari Dani. Time is over. Yes, hey, Mr. Noari Dani. Morning, people. Morning to you. The bad files. Morning to you. How are you doing? Jivesi. Hey, how are you? We are fine. Very fine. Others, please. Others. I greet my followers, please. How are you doing? For those who are new, tap on like. Tap on like, please. Tap on like there. There up. Tap on like. Tap on like. Tap on like, please. I need to increase the number of who are liking this video. You are 5. Please, you have to tap on like. Please tap on this. On like, please. Like, please. You have to like this video. One is added. Tap on like. Jojo Blaze, it's a good teacher. Thank you very much. Start to explain mathematics. Of course, I am going to try, please, to deal with this question here. Someone has asked me this question. It is what we are going to explain. I am still waiting the others. Yes. Jojo Blaze, good teacher. Thank you very much. Start to explain. Of course, I'm going to do it. How are you? I'm so fine. And you? Tap on like, please. Where are you from, sir? I am from Math Champion. I am from Rwanda in Africa continent. And you? Remember, if you are new, remember please to subscribe. Also tab on like. Thank you very much. The one who asked me, where am I coming from? I am the one from in Rwanda, in the Africa continent. Thank you for teaching. Thank you very much. Emmanuel Ni. Thank you. Nichiza, thank you. I'm from India, the one maths champion. 7429, you are from India. You're welcome. But here we are in Rwanda. I am the one from Rwanda country. How is it there in India, please? How are you doing? How is the climate there in India? Murisa Janvier, how are you, my teacher? Thank you very much. I'm so fine. And you? Please, we are going to continue by integrating this question. So I have seen this question from someone here on my YouTube live chat, right? The one asked this question, but we had a short time for explaining it. So now we are going to explain this question so fast and we continue for the next one. Now here is winter. Oh, very good, very good. The one perfect. I'm from Netherlands. You're welcome. The one from Netherlands. Scovia, how are you, my teacher? I'm so fine. You're welcome. The one morning people. Please, you have to deal to chat with the one who are asking you, how are you, please, or he just saying morning to you. The one called the Buddha files. Please, others, tap on like, yes. Please leave a message with your phone number code. Please, I should give you my phone number. Only that. I don't have a code. Excuse me, I'm going to look for it. The one who needs my phone number is 007. Let me tap my phone number. 2756626. That is my phone number. Yes, you should start by writing our country code. It is +25, and you have to add those digits of my phone number, right? Now let's continue by integrating this question that I have given by someone. Others will come after, I think. Yes, others, good evening, good evening. The one who is new, remember to tap on me. Like the one called Jojo Blaze, no. The one Anshika Jaina 911. Good evening. And you, good evening. Hi, Akariza. Akariza, how are you? Tomorrow is M6 maths exam. Oh, I wish you please to have a nice exam. For the one who has an exam tomorrow, where do you come from, please? Please, no worry, I don't have a code. I don't have a code. Please, I'm going to look for it. Please, don't worry. Tomorrow I will give you my code. Isn't it? It's well, teacher. Thank you very much. Morache Divine, thank you very much. Bahati, thank you. I came from China. Oh, good. I'm in 9th grade. Thank you. You are in 9th grade. Tomorrow you have exam. Is it national or it is the exam from your class? But you are in which country? Because here we have many people, please, or many students. You have to tell us where you came from. I mean the one called who has number 911. Tell us, please, your country. Shikajaini, yeah. Thank you, Nyonguru. Let's start explaining the integral without getting bored. Thank you very much. Are you going to be bored, Mr. Jives? For those on you, tap on it, please, on like, and remember to subscribe. Yes, the one called the Wama or Reverend. Hello. So now let's continue. You have to follow, and others should do discuss according to how the lesson is going to be. Passing through Murisa Janvier, you teach well and in a way that is understandable. Thank you very much. But you don't clean, please. Sir, do you remember? I have asked you this question. Is it this one? The one from the one? Are you from India? Tell us, please. Even if you are the one who gave me this question, I'm going to explain it, please. The one called somewhere GT7431. Are you from India? Yes, sir, from India. Thank you very much. Is it this a question that you have asked in? Yes, those who are new. Hi. Tell us, is it this a question? Yes, sir. Thank you very much. Now let's explain it, please. I was just waiting. If you should reach here, it is so very important. Please, you have to follow this question. It is what you have asked me. Sir, I am scared for tomorrow exam. Sure, don't be scared, please. But at the time, it is better, please, to tell me what I have to prepare for you so that you have a good exam next time. Right? Don't worry for the exam that will pass tomorrow. So now let us continue by explaining this question. But for the one from grade 9, this, sorry, please, this question, it is concerning for those who are in grade 12. So, but anytime we will start about this one, don't worry. So, you guys, thank you, you're welcome. You are missed. I want to ask question. Don't worry, please. But I have to do this, and we will ask questions after. Thank you, and we are accept you. Thank you very much. So now let's continue. The one help us a lot. Jean-Claude. Thank you. Now let's explain this question. We really have, this is an integral, you see? So about this integral, what should we do before doing all steps? We have a numerator and denominator here, right? So about this, you have to factorize this denominator. It is partial integral, it is partial fraction because we have a numerator and the denominator. We are going to integrate this x minus x power 3. We have given integral of dx over x minus x power 3. Now let's factorize x minus x power 3. Clear? Now how should we factorize this one? You see, common here, what you have as a common, it is x. It means that we put x in factor of, here we remain with the 1 minus x square. You have to do this one. I think we are so together. Now it is We are going to take this and we write this in the place of this one. So finally, let's have an integral of dx over this one is equal to this one. It is x factor, right? Factor of 1 minus x square. Are we together here? So now finally, after factorizing, you see this is the first factor. Also here, we have another two factors. Because if you have, for example, let me write here. Sorry here, a square minus b square. By using this quadratic formula, we should have, it is a minus b times a plus b, right? So you see, here we have the form similar to this form that you have here, right? This is a square because 1 times 1 is equal to 1 square, which is 1, right? Then here we have a square minus b square. That is what you have in this formula. We are going to convert this into this factor form. Then after, we are going to convert also this quadratic equation into its factor form. Then we still have integral of dx over x times 1 minus x factor times also, because we have two factors. Here we have quadratic equation, then it is 1 plus x. Clear? It means that we have 3 terms. Focusing on what you have here. We have 3 terms, then let's use partial substitution. Right? So now we have an integral of dx over x times x, 1 minus x, this one, cross the bracket, times 1 plus x, cross the bracket also. So now here we are going to make a supposition, right? So allow me please to write this one. This is 1 because 1 times dx is equal to dx, right? So we have 1 over this denominator x times 1 minus x times also 1 plus x, close the bracket, is equal to, how many factors do we have here? We have 3 factors. 1 factor, second factor, and third factor. It means we should suppose 3 letters. We have a over this factor, the first factor, over x plus b over the second factor, 1 minus x plus c, because we have 3 factors over x plus c, 1 plus x. Are we together here? Then finally, we are going to find the common denominator. So here we have 1, you have to write this over this x times 1 minus x times 1 plus x, right? Then it is equal to this one. Let's find the common denominator of those 3 factors. We really have x times 1 minus x, or cross the bracket, times again 1 plus x. Then after finding this factor from our 3 factors, we are going to take this whole factor over the factor that you have here as a symbol. Then we remain with it is 1. This is h times, we take all factor over x. We have to simplify by this. Then we take this factor times this a. It is 1 plus minus x times 1 plus x. You have to use two brackets, because we have this A, will come to multiply to whole factor, right? Then plus this over to this one. We remain with this will be cancelled. We remain with x times this one times to this b. It is b times right? X times again 1 plus x, right? Then you see here, I am reaching here at this point. Are we together? Excuse me, my lovely dear students. It is b times this x times again. This is, we remain with 1 plus x, right? Then plus c. Let me write it. Plus c times this factor over to this one. This will be cancelled with this one, remain with this times to this one. Then it is x times 1 minus x, right? Remember, this is a common denominator of this plus to this one. Clear? Are we together? So, now let me come to this part. Let me come to this part. Finally, we should have 1 over x times x 1 minus x times 1 plus x, right? Which is, let me write it, all equation. It is a times 1 minus x times 1 plus x, right? I'm writing this one. Then plus b times x times this one plus x plus c times, we are reaching here, c x times 1 minus x. Clear? Over, this is the common denominator, I'm sorry. It is this common denominator, x times x minus 1 times x plus 1. And this is the common denominator. It is x minus 1 times x plus 1. Then you see, this is similar to this one. We are going to simplify this and to this one. Then we remain with 1 is equal to a. It is a times 1 minus x times 1 plus x plus b times this x, close the bracket, times open the bracket 1 plus x, close the bracket, plus c times x, the bracket, times 1 minus x. This minus x cross the bracket. Are we together here? Now we are going, what we are going to do, we are going to remove these brackets, right? We are going to remove these brackets by multiplication law. He helps us a lot. Thank you very much. Hello, sir, from India. We are welcome. If you are new, remember to subscribe. Also tap on like. Now. Thank you very much. Now. Yes. Explain step by step. Thank you very much. Now, the one from India, please. How are you doing? Please remember to subscribe for those who are new and tap on like. So let's continue. We remember we really have 1, which is, it is 1. Let's take this one times to this one. We remain with 1. 1 times to this x, we remain with plus x. X times to this, we remain with plus x. then x minus x times to this x, it is minus x squared. Together here, then you have to use a closed bracket, plus this b times this x times to this one, it is x. X times to this x, it is plus x squared, close the bracket, we are reaching at c, plus c times, we take this x times to this one, we remain with x, excuse me, then let me do like this. Clear? We take x times to this one, we remain with the x. X times to minus x, it is minus x square, then close the bracket. Are we together at this step? He helped us. Thank you very much. So now here we have one. We are going to take, excuse me, here it was a. Here it was a. Please, you have to remind me. This was a. It is what you have here. Other one is no problem. Clear? Now let us continue. So now we are going to remove this bracket by multiplying this letter into the side parts. So now we take this time to this one, which is equal. It is a. Are we looking here down? Yes. A plus, right? Here it is plus. Yes, sorry. It is x, right? I did a mistake here, please. Isn't it or not? I'm sorry, please. Here it was a plus. Very good. And here and this one, there is minus. Here it is minus. Then we have to cancel this and this one. We remain with it is a times 2. 1 we remain with a. And a times 2, it is minus ax squared, close the bracket, we have to remove this bracket, plus, here we have this times this one, it is bx plus bx squared plus c times x, it is cx minus cx squared. Then finally, let's come to this side. Dear friends, hello. Now, if you are reaching here, you know here we have this is 1. It means that you have to complete this polynomial. We have to complete this polynomial because here in our question we have this polynomial which has x power 2. How should you complete this polynomial? It means that we are going to start on, we have 0 x squared, because here we don't have x squared. According to what we have in our polynomial, it is what we are going to use by completing this one. 0 squared, something that cannot change what we have in our polynomial, plus 0x, because here we don't have that one, plus that one here we have, then which is equal to ax squared, it is this one, plus bx, right, plus here bx, yes, plus bx squared, right, this one, plus also cx, plus minus the last one, last factor, it is cx squared. Are you looking there? cx square. This is square here. Now, we are going to arrange them by focusing on their polynomials. Where we have the same power, we have to write them. Right? Now, let's start on this one. Let's use this curly bracket, which is 0x square. It will be where we have x square in our second or in our right side. It is at a x square and this one plus bx squared and minus cx squared. Right? Now we are reaching where we have x, which has power of 1. It is 0x, which is where we have x, it is only plus bx, then plus cx. The last one, it is where we don't have a variable. We have only a number, it is this one. Then 1 is equal to where I have forgotten this a. Excuse me, I have forgotten this a. It was a minus. Yes, it is what we have here. I'm so sorry. It is this one, and here we have minus. Right? Then we have a. So now let's continue by factorizing where we have x's. So we put factor of this x square, the factor of 0 is equal to, here we have the similar x squared. Then we put x squared in the factor of minus a plus b minus c, right? And here we have x, the factor of 0, which is x factor b plus c. Then you have to add 1 is equal to 2a. Then you have to simplify this and this one, and also this to this one. After, we should have minus a plus b minus c is equal to 0. Right? And b plus c is equal to also this 0. Then the one that you have seen, it is a, which is equal to 1. Right? This is a simultaneous of 3 unknowns because we have a, b, and c. Then finally, let's have where we have a is equal to 1. Then let's substitute this a in our first equation here, where a is, right? Now, first equation we have minus a plus b minus c is equal to 0. This a is equal to 1. Now let's put this one in the place of a, it is minus 1 plus b minus c is equal to 0. Then b minus c is equal to 1. Right? I write this one, and here it is the minus 1 from first member to the second member. This sign will be changed into positive. Right? Now, here we should combine those, and we remain with this equation. It is b plus c is equal to 0. Then the one which is easy, let's find the value of this b. Then b is equal to b plus c is equal to 0. Then b is equal to minus c. Now let's take this b and we put this b in our equation here above, right? The one that you have here. Let me use this part. Then finally, B, we substitute this B in this equation. Where B is in this equation, we have to put minus C. It means B minus C is equal to 1. Then finally B, it is equal to minus C. Minus C is equal to 1. Minus 2, this, it is minus, here we have 1, and here we have 1. Here 1 plus 1 is equal to 2. And write 1 letter among those two letters. We really have, it is minus 2C is equal to 1. Then this is the coefficients of C. We have to divide this C on this minus. Then it is 1 over minus 2, right? Then finally C is equal to minus 1 over 2. This is our C. Remember how is it? This is H. So now we are going to find B by focusing on this that you have here. B is equal to minus C, right? Let me come to this part. Now, here we have B is equal to minus C. Then, remember C is equal to this minus 1 over 2. Now let's substitute this C by its number. Then B is equal to minus, this minus times the letter C is equal to minus 1 over 2. Finally, our letter B is equal to this minus times to this minus will be positive. Then we remain with 1 over 2. Then you see, this is our B, right? So our equation, it was how to integrate, right? It is A over X plus B over X minus 1 plus C over X plus 1. So it was what you have that as our factors. Then we are going to integrate this one, because first, before integrating, you have to substitute those letters by the number that you have seen here. A is equal to 1, B is equal to, this is B, 1 over 2, and C is equal to minus 1 over 2. Finally, let's substitute. This A is equal to 1 over X plus B is equal to this number. It is 1 over 2 over X minus 1 plus, how is C? C is equal to minus 1 over 2. It is minus 1 over 2 over this denominator X plus 1. Then finally, let's integrate our given problem. Let's integrate our given problem, please. Then the problem, it was the integral of dx over x minus 3. Sorry, minus x power 3. It was this equation. Remember, we have transformed this one into factor form as what you have here. It is integral of 1 over x. Yes, let's use this one. Plus, if you have this kind of fraction, for example, we have 1 over 2 over x minus 1, right? So we have to take this in the come to multiply to this number, and we remain with the 1 over 2 times x minus 1. Clear? Where we have this kind of fraction, we have to change this into to this one. Now, it is what we are going to do there. We have, this is 1 over 2 times this, it is x minus 1, plus, here we have plus times this negative or this minus, then it will be minus. We have to clean this, remain with minus, then 1 over 2 times this factor, x plus 1, close it 1, right? Now let's make an integral, and you have to put, excuse me, let me write this in a good way. It is 1 over x times, 2, this is 2, times x plus 1, closed, and we use this bracket, put the x here, because we are integrating this equation, and this equation was transformed into this one, right? That is what you have to add this dx there. So now our equation was dx over x minus x power 3, which is, it is better to integrate each term. Yes, each term we should integrate it, or you have to use it randomly, but let's use each term step by step. Then it is integral of this times to this one. We remain with the dx over x plus this dx times 2. This will remain with the integral of dx is each step over this is 2, right? Here we remember we have 1. It is times x minus 1 minus integral of dx over 2 times x plus 1, right? Are we together here? Remember, I told you, if you have dx is equal to 1 times dx, are they similar? Now, where we have dx over 2 times x minus 1, it means that it is 1 over 2 times dx over x minus 1. Are we together here? It is what you are going to apply here. So, now we have integral of dx over x minus x power 3, which is, now if we have this kind of, let's use this dx over x plus, let me clean this, plus here we have 1 over, this is 1 over 2, integral of dx over x minus 1, that is what we call step by step, minus, here we have 1 over 2, integral of dx over x plus 1, right? Then after you're going to integrate. So where we have dx over x, we have to use ln absolute value x, right? And there we have dx over x plus 1, it will be also ln of absolute value of this denominator x plus 1, right? So this should be applicable where we have the denominator has here at variable x has a power of 1. You have to apply this one immediately. Let me repeat once again. If we at your denominator, you have a power of 1, you have to use this formula. But here, you should have only dx. When here there is a number, for example, 2 dx over this, it means that, for example, if I have given this one, it means here before ln, we should have 2 ln of that x, right, plus constant. Clear? So now here you have to see, am I given here at variable x a power of 1? If yes, you have to choose this one. Clear? So now an integral of dx over x minus x power 3, it will be, here I told you this is about to use ln. ln of absolute value x plus 1 over 2, right? Also, ln of absolute value x minus 1 minus 1 over 2, ln of absolute value x plus 1, then you have to close this absolute value plus constant c. Now, because you add this constant c, because we are on indefinite integrals, they are integrals that can be definite, right? So now, for definite, finally answer, we are going to write the final good answer here. Then integral of dx over x minus x power 3, it will be ln of absolute value x, this term, plus the next one, it is 1 over 2, ln of absolute value x minus 1 minus 1 over 2, ln of absolute value x plus 1, then plus constant c. So this is an answer that you have here. But we should also change this into other forms. But if you are just reaching here, that is a complete answer. This is a complete answer. Now it is the question that I have been asked by someone. Yes. Now let's see whether the one who has asked this question, is he satisfied? That is your time for discussions, please. Hey. Back up, please. Back. Return back. Return back, please. Please, others, where are you? Where are you? Have you gone? Time for discussions, please. I have 30 minutes for being here. 30 minutes for discussing. Where are you, please? Others, where are you? Who is new here, please? Next question. Next question. So good. Thank you very much. Next question. So today's it was about question that I have been asked by someone. That is why I have completed what I have been asked. Right? So now if you have another question, please you have to type it please in the comment box and we should see or discuss about it, please. Because today it was about an integral for the questions that have been asking. Tomorrow I will prepare for you questions concerning limits. Because on Saturday we have seen about asymptotes. I see many of you have been confused. I've been confused, so can we solve it by parts also? Please, can I give you a question to do personally? By part, of course, don't worry. Let's do, by part, I should do it tomorrow, please. Today it was about this one. Also, the one who asked about by part, let me give you a short, simple for by part. How should you, or how should we do a questions concerning to by part? Like, for example, you have this kind of, this is an integral of x, for example, x power 3, power e power, so this is times e power, for example, 2. For example, this one. Right? We should do this question, add dx. You have to integral this question in by using part method. By part method, x power 3 times e power x dx. How should we do that by part method? I'm keep waiting you, please. Please, others, where have you gone? So the one who was asked the by part method, let's use by part method. For by part method, what should we do here? You see here we have, this is x power 3. It means that you have to use here derivative, right? And here we have to use integral. So when we are integrating, for example, it is as for integrating integrating a given function, but here D, it is about derivative. Derivative. Where we have R, it means we are going to take a function and make it its integral. And where we have D at this, we are going to use a derivative. So now it means that we have those are two functions where we have x power 3 and e power x. The first function where we have x power 3, we are going to make its derivative, and the e power x also we are going to make its integral. So it is by part method, as someone asked a question. So now let's take e x power 3 and e power x. The first one, you have to make derivative. Derivative of this x power 3 is, for example, we have x power n, which is, it is n, you take this n times x, right? And the x power, that n minus 1. This is a derivative. Then it is what we are going to do at this x power 3. It is 3 times x power 3 minus 1. Then it will be 3 times x squared. The first derivative of x power 3 will remain with the 3x squared. But integral of e power x will remain with the e power x. Right? The next one, we are going also to make this up to 0 derivative, where the number that you have as a constant, we have to make it, finally we should have 0 as the final number. So now the derivative of 3 times x squared, it will be, this is 3 times this n times our x power n is equal to this number 2 minus 1. It is derivative, we are in decreasing function. Now we remain with the 6 times x power 1. We remain with the 6x. Derivative of this 3 times x squared is 6x. Integral of e power x is e power x. Right? Then the derivative of this 6x also will remain with 6 times x is, here on x it has a power of 1. Then it is 6 times that power 1 times this x power 1 minus 1. Right? Then we remain with 6 times x power 0. Any number power 0 is equal to 1. Then we remain with the 6. It is the derivative of 6x, it is 6. Integral of e power x, it is e power x. Yes, the one who is coming, sorry, hello, hello. How are you? So, you are coming, sorry. Now, finally, we have to find the derivative of this constant number. It is 0. Integral of e power x remaining with the e power x. Then you come to our equation, you put positive here, here we put negative, positive, negative, positive. Then you take this to this one and this to this one, then 6x to this one, also minus 6 to this one. Finally, you have to write, yes, we have to write this. It is plus this x power 3 times to e power x. It is x power 3 times e power x. This minus 3 x squared times e power x plus 6x times e power x minus, this is minus 6 times e power x plus constant c. Then finally, our original equation it was integral, are you looking here, of x power 3 times e power x is equal to, this is x power 3 times e power x minus 3x squared times e power x plus 6x times this e power x minus 6 times 6 times e power x plus constant c. Right? Excuse. Plus constant c. This is our final answer. It is a final answer for this kind of integral by using parts method. I think for the one who has asked that question, you're satisfied. New people joining class now, lot, of course. Others have gone. Today you're so joining you're so few. New people, please. You have to subscribe. You have to subscribe, please. Please, others, I have missed you, please. Others, try to react, please. Yes, sir, thank you very much. Where were you, please? Where were you? Can you solve it by part? I think well solved for the question that you have asked. So, new people, nice seeing you a bit success now. Thank you, sir. Thank you very much. But you are so late. Please. Today you missed you. Now you come now, you see. So some progress has been made. Oh, be sorry. I see you can't miss, but it was some issues, right? So others, where are you? Others, please, where are you? Why can't you react, please? Why can't you react? You have to react, please. I have missed you. Let me use this side. If I am in front of you, can't see what I have explained here, right? Some progress here. Yes. The one called Tiger Sloth, you are a good teacher. Thank you very much. Thank you very much. Thank you. So I see from right now, my light is somehow dangerous. So please connected. I'm going to solve or to handle this problem. I'm in progress, please, for handling this problem. It's late, of course. Of course. Which country? Are you asking me where do I live? from India. Thank you. Others, for those who are new, remember to tap on like, please. We were discussing about questions relating to mathematics. Can you explain new sub, please? Oh, please, if you say that is sub, yes, sub should help us, please, to increase our channel. Yes, to increase the number of those who are seeing our channel, please. It is better to subscribe, right? Let's support, please, one by one. It is better. It is better. Don't leave without tab on it, like and subscribe, even your comment, right? I'm keep waiting you. Have you done it? The one who has asked me about sub, do it, please. Do it. Try to support us, please. So now, let him ask you, for those who have rated, what can we do, please? Remember the time that you have precised. Thank you very much. Nice seeing you a bit successful now, sir. Thank you very much. Even if you are so late, but you have excused, right? Like Denjikun, you have so excused. Thank you very much. So remember, tomorrow, please be on time, as I told you. Of course, at 5 and 10 minutes. The one who will rate, please don't go above those hour. At 5 and 10 minutes, it is better, right? Sir, I was studying other subjects. Sorry, sir. Thank you very much. Even if you were at school or you were in other subject, other courses, please, it is better. But I see a promise is a promise. You can't forget what you have been discussion. We taken as a discussion. Yes. So I think tomorrow we will be on a time. Tomorrow we shall see about limits, because last Saturday we discussed about asymptotes. I see that there was a confusion, so I am going to prepare for you another courses concerning two limits, where we shall discuss different concepts relating to limits, right? Please don't miss tomorrow. I told you, please, we have to end up. We have to end up in 9 minutes, 8 minutes. We remain with 80 minutes, please, for ending this today session. You are there. Thank you very much. Thank you very much. Even if you see that what you're just saying, yeah, it's good. Thank you. I was sneezing, excuse me. So now we remain with 5 minutes for ending this today's session. 5 minutes. You are in class 8. So now I have seen there are so many students who are here in different classes. So now in class 8, I'm going also to prepare another contents concerning to your class. Don't worry. Yes, the one from 8, class 8, 9, 10, 11, 12. Yeah, now I am just focusing on 10, 11, 12. So now I am going to come down for those remaining classes, right? Don't worry, please. I am going to see how we should do gain another things like those who are in those above classes. I have done university level 3A physics. Oh, thank you very much. Not lying. Thank you very much. Yes? Thank you very much. If you did, please, physics in university, thank you. You're welcome. You're welcome. Even me, please, I did mathematics in university. Yeah, I am interested in quantum physics and general relativity. Thank you. Wow. So I remember about quantum. I did quantum in level, yeah, level level 1 and 2 in university. We did about quantum. But the remaining levels 3 and 4 and 5, I did only mathematics. Yes? Yeah, yes, thank you very much. But don't leave, please, without tab on. Like, also you have to subscribe. Support us, please. That is, but tell us, please, where do you live? Shika, tell us, where do you live? Tell us, where do you live? The one called Shika. I'm from, oh, please. You are so, let me say, you are so intelligent. The people from India, so intelligent. Because you are the one who knows how to use social medias. I like the way you are acting. Very nice. Not also, please, you are so the one who really know many things, right? You see, even if you are just going in different movies, you are the ones, right? Another different things or activities, you are the ones. So the one called the Charlotte Kankundiye, byiza cyane. Thank you very much. Charlotte, you're welcome, you're welcome. I greet you. Hello, Charlotte. Yes? Now, thank you. Nice to meet you. Thank you very much. But I like the way you're acting, please. People from there, India. I want to become a physicist like Estienne. You're welcome. You're welcome. You will, please, you will. But the most, it is better to do and to make a research, different researches, right? Yes, for those who are new, please don't move without subscribe, please. I really, please, need your support. Charlotte Kankundiye, you are so late, you are so late. The one from Rwanda. The one from Rwanda, please. I told you, the time that I have precised, I am doing research on desk math and unifying quantum physics and general relativity. Thank you very much. You're welcome. You're welcome. I really know you will do them, please. The first, don't be discouraged. Yes, try and more. You will, of course. Okay, bye. Thank you very much. But have you done my support of subscribe? It is 11 p.m. here, but here in our country it is 6:31 p.m. Here is 6:31 p.m. Yes, thank you very much for your support. Thank you very much for your support. Sorry is yeah. So for those who guide this, thank you very much. So Shkala very much. Yeah, you see another one. You see, yes, the Njikun. You see the one who is good at physics. What's Planck constant? Please, you are going to ask question is writing. Oh, mathematics is good. Charlotte, yes, very, very good. It is good, of course. You didn't know it is also tool used to gain or to do other different activities, even if in engineering. Right? So, but I have to remind you the time that we start our courses for those who are new, from Monday up to Friday, we start our lesson at 5 o'clock p.m. Right? At 5 o'clock p.m. Tomorrow we will start at 5:10 p.m. It is when we will start our courses. So let me say goodbye for those who have participated. Please, people from there, India, much respect, right? Because you are the most ones who know how to use social media. Thank you very much. Even those who from my country here in Rwanda, thank you very much. The one called Charlotte, you are welcome for acting in this platform, right? So let's meet tomorrow at that hour that I have told you. It will be 5:10 p.m. Yeah, Planck constant is a constant made by X Planck that is virtual part of our universe. And thank you, thank you. Denji Kun, have you satisfied? Dekun, have you satisfied a virtual part of quantum physics? I'm keeping waiting the answer of that person who asked about it. Planck constant.